due to the presence of lone pair on the nitrogen atom of amines, it is classified as a nucleophile, which is a Lewis base. So the strength of the base is depends on the ability of the lone pair electron on the nitrogen atom to be donated to the proton, and also the stability of the conjugate acid, which is the alkyl ammonium ion form. Let's have a look at the first effects on basicity of amines. So we have an inductive effect, which is the presence of electron donating group. So alkyl group is an example of electron donating group. The presence of alkyl group will increase the electron density on the nitrogen atom. So for primary and secondary amines, the basicity of amines will increases with the increasing of alkyl group. This is due to when the number of alkyl group increases, the electron density on nitrogen atom increases, so the lone pair electron can be easily donated. Thus, basicity also increases. Okay, so kita tengok pada electron density on the nitrogen atom. So, if we can increase the electron density on the nitrogen atom, so lagi banyak electron pada nitrogen, lagi senang dia nak donate kepada proton. Since amines is a derivative of ammonia, okay, both are a weak base. When it dissociates in water, ammonia will form an ammonium ion while amines will form alkyl ammonium ion. Okay, the pKb value for amines is lower than ammonia. So this shows that amines has higher basicity compared to ammonia. Why? Because the presence of the alkyl group in amines will increase the electron density on nitrogen atoms. So that's why amines has higher basicity compared to ammonia. So the lower the pKb value, the higher the Kb, it will become more basic. For the inductive effect, which is the presence of the electron donating group, we are going to divide it into two conditions. The first one is in the gas phase. In the gas phase, the tertiary amines has higher basicity compared to secondary amines, and then followed by primary amines, and then ammonia is the least basic. Okay, this is due to the presence of the alkyl group. Basicity of amines increases with the increasing of alkyl group. However, in aqueous solution, the basicity of amines is arranged as follow. Okay, so secondary amines is more basic than primary amines, and then followed by tertiary amines, and then ammonia is the least basic. So between secondary and primary amines, secondary amines is more basic due to the increasing number of alkyl group. Alright, so since secondary amines has two alkyl group while primary amines only has one alkyl group, alright, as the number of alkyl group increases, basicity also increases. But then for the tertiary amines in the aqueous solution, alright, the steric effects refers to the crowding of alkyl group surrounding the nitrogen atoms. So we have three alkyl group on the nitrogen atoms, which hinders the attack of the proton on the amines molecules, and it decreases its basicity. Okay, so if the question asks you to arrange the basicity of amines, kalau dia tak cakap, dia tak mention about the condition, okay, kita akan anggap, okay, just assume that the condition is in aqueous solution. Alright, so kita anggap dia dalam aqueous solution, so that secondary amines is more basic than primary, followed by tertiary, and then ammonia is the least basic. Okay, ammonia ni sebab apa dia paling kurang basic? Because there is no alkyl group present. Okay, so we know that the presence of alkyl group, which is the electron donating group, will increase the electron density on the nitrogen, and then it will make our amines more basic compared to ammonia. The presence of electron withdrawing groups such as the nitro group, fluorine, chlorine, bromine, and iodine will reduce the electron density on nitrogen atoms. Okay, so the presence of electron withdrawing group will decrease the basicity of amines. Next, let's have a look at the resonance effects on the basicity of amines. Okay, so kalau resonance effect ni, we focus on the aromatics amines, which is aniline. So the aromatic amines is a weaker base compared to the aliphatic and cyclic amines. This is due to the delocalization of electrons into the benzene ring that decrease the electron density on nitrogen atom. So dia menyebabkan bila the lone pair on the nitrogen delocalize into the benzene ring, the electron density on the nitrogen decreases. So here we have aniline and cyclohexylamine. Okay, so the pKb of cyclohexylamine, this one is our cyclic amines, is lower compared to our aniline. Okay, so bila pKb dia rendah, so we know that the Kb value is higher, so it is more basic. So the delocalization of the lone pairs on the nitrogen atom into the benzene ring will stabilize the aniline. Alright, so the decrease in the electron density on nitrogen atom will make aniline less basic compared to alkylamine. So let's do some example. Arrange the following compounds in ascending order of basicity. Explain your answer. Okay, so we have the IUPAC name of the compound. Okay, so first let's draw the structure. Right, so we have ammonia. Okay, ammonia, NH3, and then methanamine. So methanamine, only one carbon, CH3, NH2. Right, and then aniline. So aniline is the benzene ring. Okay, kita ada benzene ring. Right, and then we have the amino groups, the NH2 directly attached to the benzene ring. And last but not least, the para-nitroaniline. So para-nitroaniline, let's draw the benzene first. Okay, kita ada benzene and then amino group on the first carbon. Right, so para ni kedudukan 1 dan 4. So on the fourth carbon, we have the nitro group. Right, so since dia nak kita arrange in ascending order of basicity, right, so the one with the resonance stabilization effect, okay, yang ada resonance stabilization effect ni akan mempunyai the lowest basicity. Okay, so these two akan mempunyai lowest basicity compared to ammonia and methanamine. Okay, so antara dua ni pula, so dua-dua ada resonance stabilization effect, but then this one we have the electron withdrawing group. Alright, so this one dia ada electron withdrawing group and also the resonance effect, while this one only has a resonance effect. Okay, so the presence of electron withdrawing group will makes our amines less basic. Okay, sebab dia akan pull the electron toward itself. Okay, menyebabkan lagilah sikit electron density pada nitrogen atom. So the one that is least basic is our para-nitroaniline. So let's label our nitroaniline. Okay, kita gunakan label A, B, C, D. Okay, sebab kalau nak tulis nama dia dalam explanation, okay, sama je macam sebelum ni, terlalu panjang. So let's label our compound. Okay, so this one will become my compound A and then followed by the one with resonance effect. Okay, this one is compound B. Okay, and then between ammonia and methanamine, so CH3 is the alkyl group. Okay, so in methanamine we have the inductive effect, which is the presence of electron donating group that will makes our amines more basic compared to ammonia. So this one will become our compound C and then the methanamine will become compound D. So arrange it in ascending order. So kita gunakan the alphabet only. A, B, C, D. Right. So we have ascending order of basicity. Right. So now let's explain our answer. Kenapa susunan dia macam ni. Okay. So first, compound A and B are less basic than C and D because A and B are aromatic amines. So the delocalization of electron pair in aromatic amines will decrease the electron density on nitrogen atom. Thus, the lone pair is less available to be donated. So that's why A and B is less basic compared to C and D. Compound A is less basic than B because A has the presence of electron withdrawing group, which is the NO2 group. So the presence of electron withdrawing group will decrease the electron density on the nitrogen atom. Thus, the lone pair is less available to be donated compared to compound B. Last but not least, compound C is less basic than D because D has a methyl group, okay, which is the electron donating group. It increases the electron density on the nitrogen atom, thus the lone pair is easily to be donated to the proton.